All right, so let's begin with example one. So in example one, they're asking us to determine if the function is continuous. The graph below is the function f of x. So pretty much what we want to check is whether it meets the three qualifications to be a continuous function. In this example, we are looking for whether the function is continuous at a equals -1. So we notice it's right here, right? So we want to see whether this right here, this part, is continuous. By looking at the graph, right, we can kind of see that it's not continuous, but what we want to do is which of the following three conditions um, it is not satisfied, right? So let's begin with the first one. Let's try, let's think about f of a. Is f of a defined in this example? And what I mean by f of a, we mean that whether f of -1 is defined, right? And if we notice, the value at -1 is defined here, right? There's a solid dot there. So it is defined. In fact, it is positive 2. So it is defined. So it is actually good, right? So that's not what makes the function discontinuous. All right. So let's check the next one. The next one is the limit. If the limit of f of x exists at x equals as x goes to a. So we look at this. We can see the limit, right? We can see the limit of the left side. As x approaches -1, the value of the function, meaning the y value of this, is going down, 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 all the way to 3. But when you come from the right side, right, the value of the function, the value of the function is increasing, increasing, increasing to positive 2, right? So we see that it is actually the limit does not exist, because the limit as x approaches 1 from the negative side of f of x is equal to positive 3, which is not equal to 2, which is the limit of f of x as x approaches 1 from the positive side, right? So there you go, right? It fails this is the one rule that that is violated, right? This right here, that's the first one. Of course we can proceed with this one, right? Because with the next one, because you already disqualify the function from being continuous from this rule. Okay, so is discontinuity at x equals -1 removable discontinuity, or a jump discontinuity, or a limit discontinuity? Well, in this case, we will argue that this is a jump discontinuity, because in order for this function to be continuous, you gotta jump to a different y value to continue the graph, right? Another way we can argue, which is more formal, is that there's just by changing this value from here to here, right, it's not gonna remove the discontinuation. So like we said, this is going to be a jump discontinuity, period, right? All right, so I hope you guys find this helpful. We're gonna try the next example. Sorry.